let's start this. Okay, let's start with this. Maybe we should wait a couple of minutes. Okay, so let's start with this introduction to your final year project. And I will explain why your final year project is really important and why it's important to start thinking about it right now. Okay? So hopefully when you will be on holiday or doing other things, you will keep in the back of your mind that you have your final year project coming and maybe think about ideas and things. Okay. So first of all, I would like to define what the final year project is. So first of all, one way of looking at it is to see that it's the pinnacle of your academic achievement. Okay? So when you will have finished your time at the university, you are not going to meet people and say, yeah, I got an A in IT Toolbox, because nobody knows what IT Toolbox is about. They will ask you, what have you done in Kingston? And you will speak about your project. Okay? So somehow the project is going to summarize all the knowledge that you will have acquired during your time at university and demonstrate how you have applied it in order to provide a solution to a specific problem. Okay? So you will obviously in that project showcase your skills and expertise. And obviously, when you will go to a job interview, can give you a trick, they will ask you a question about your final year project. Okay? So make sure that the final year project, the topic, and what you will have achieved is relevant to your future career. Okay? If you want to work in the game industry, making a video game as your project may be a good idea. If you are interested in banking, maybe some web service dealing with banking would be a good idea. It's important for your future employer, but also it's important if you wish to carry on your studies, maybe doing a master's or a PhD. Again, if you go to an interview, people will ask you about your final year projects. At that stage, people are not interested in your marks anymore. Okay, you have your degree, you get a first, a 2-1, a 2-2, a third. They know how clever you are. They don't care about your marks in different specific modules. They want to know what are you able to do. What have you made during your 3 years time? And you can say, I have made that. And you can show it to your employer, to the person who is going to interview you, whatever you want to do after your degree here. So this project is going to be very important because professionally, it's going to define you for a while. Okay? They will say, yeah, this guy is coming from Kingston and did a project in e-commerce. So he's an e-commerce guy. Okay? So that's how people outside are going to see you. So it's very important to choose an appropriate topic for your final year project. And possibly, if the job you are looking for is related to your project, you are going to write it down in your CV to highlight your specific expertise. You have worked already for more than 6 months on the topic that people want to employ you for. So that was one way of looking at the final year project. Another way of looking at it is that it's a major piece of work. Okay? It's a whole module, 30 credits. So it means that you are expected to spend at least 300 hours on that topic, on that project, which means it's 10 hours a week, every week, from end of September to the end of the second teaching block. Okay, so it's a lot of work, and it's a big commitment. And you can understand that those 300 hours is quite difficult to squeeze them in the final 2 weeks. Yeah? So it's good to have a good pace, you know, doing your 10 hours a week in average. Maybe at some point during the teaching block you will have exam in other topics, so you will leave your final year project for a week. So make sure that the following week you do your 20 hours. Yeah? So obviously it's an opportunity to practice all the different skills that you will have acquired at university. It's likely to be the largest project that you will have completed so far. And also what is important is something that you will have done on your own. It's going to be something original. Nobody will have done that before. It's your topic. And finally, the project manager, it's you. It's not your supervisor. It's not any member of academic staff. You are the project manager. Okay, so short break. So a final year project is a deliverable. Okay, you will be asked in mid-October to provide a project proposal, and you will be in that project proposal defining what you will be delivering at the end of your project. Okay, so the project has a clear endpoint. So since it's a lot of work, you're going to spend a lot of time on that, and it's likely to have a big impact on the start of your career as an IT professional. So it's a good idea to work on something you are interested in. Okay? Don't take any project which is around because, yeah, I don't have any idea. This lecture, quite nice, offering a project and just pick that one. Now that's not a good strategy. Okay? You need a bit of passion if you want to do well. You know? Working all those hours when it's sunny outside may not be that easy. Typically, your project will have a client. Okay, you have done quite a lot of modules on analysis and design, looking for example, the requirements, functional requirements for a project. If you don't have a client, it becomes a bit difficult. Okay, you need to invent, to pretend that you have a client, and when you write a report, it doesn't sound quite right. Okay, so usually the best projects have a client. It's not compulsory to have a client, but already it gives you a boost, and you have a better chance to get a higher mark. So if you have a client, it's the opportunity to create something hopefully useful for someone else. Okay, so there is this sense of achievement. I've done something useful. Obviously, the final year project should be in line with your course. Okay, so if you are on a security course, it would be a good idea to have a project which is building on your security skills. Okay, obviously, if you are doing a course which is quite general, like computer science, then any IT project would be appropriate. So in your project, you want to demonstrate a variety of skills. Okay, somehow you want to show off everything you have learned during your time at the university. Because eventually the marks that will be given, it's about your technical skills. Okay? You want to be original, creative. You don't want to copy a project which has existed already. You want also to demonstrate ability of critical thinking. So the skills we are looking at are obviously technical skills because you are on a IT degree, but it's also about critical thinking. Okay, so anybody with a degree should be able to demonstrate those type of skills, which are very important as well. And finally, in average, the reports you will be generating will be around 50 pages. Okay. So still quite a thick report. And you need to be able to put forward what you wanted to achieve, what was the rationale about your project, what was the literature review associated with your project, how did you generate the analysis, the design, how did you implement your design, how did you evaluate the final project, the final product, and eventually some critical review about what you have done. So you need a very coherent argument that you will need to make fit 50 pages. And the topic you are going to work on, it's likely that it's going to be quite narrow. You will have a client which will have a very specific problem. They will need a specific system for their specific problem. But you need to be able to look at the world in a wider context and see how this specific product or project fits within the whole scope of IT. So, for your Excuse me? But we were supposed to finish at 4, according to the timetable. Sorry. That's all right. So there are 3 types of projects that you can choose. First type is called a build project. Second one is called a design project, and the third one is a research project. And it's very important that you choose the right type of project, because each type of project has a different marking scheme. So why have I lost the display on my screen? I don't know. Okay. Okay, so what is a build project? So basically a build project is where the delivery is some kind of product. Okay, so typically it will be a piece of software, a website. Yeah. So I give you some examples. Could be some kind of image processing software, that could be running on as an app on a smartphone, could be a video game, could be an e-learning system, or maybe a custom web applications, typically an e-commerce website. Okay, so that's the build project where the final delivery is a piece of software, something that can be used. The second type of project is called the design project. So here, it's more about, obviously, as you could expect, the design, about the modeling, about the simulation. So, for example, if you have to deal with a very complex system, you may design a novel information management system. Okay, so you can imagine that a system with hundreds of tables will require some very advanced design. And because the design is so complex, we are not going to ask you to implement it as well. Okay? So most of the points of the marking will be on the quality of your design, and we'll be expecting, in terms of implementation, just a prototype with a few tables demonstrating that your design is sound. Okay. If you are dealing more with networking, again, we are not going to ask you to get some cables and connect machine together. It's likely that you are going to use a simulator. You are going to design some kind of network with security and so on, and they would fit very nicely in the design type of project. You could also design some kind of theoretical framework. So that's more on the critical thinking way, novel ways of designing systems, for example, for a business information system. Okay? The third type of project, and that's the type of project that students very often have difficulties to understand. So it's called a research project. Okay? And the photograph that I've put is to give you a good hint about what research is about. Okay? Research is not about doing a literature review. Okay? It's still about making things, making something original. It's not just reading a few articles and generating a summary. Okay? That's not the type how we define research in this context. So basically, research is you want to contribute to human knowledge. Okay? Very different from the other types of projects where you are delivering a solution to a problem, okay? But it's a development type of project. Here you are going to try to do something which has never been done, or look at something that nobody have looked at before. Okay? So the project aims at contributing knowledge. Okay? It's like when a probe is going to Mars, we are aiming at finding a proof of life. Maybe we'll not find a proof of life, okay? But it's still the aim of the project. So a research project doesn't need to be somehow successful in getting that aim, but you need to have put together all the architecture, the framework required to get it. Okay? If you go to Mars and you demonstrate there is no life on Mars, it's a great success, even if initially you were looking for life. Okay? Obviously, those types of projects are the toughest ones, so they are really for students who are aiming for a first. Okay? If you are not in that category, I wouldn't try to go there. So you want to do something which has never been done before. Okay? We don't really know if it's possible to do it. Okay? That's where the research is going. You know, it's investigation, trying to do something that nobody has done before. Obviously, in order to do that, you are going to apply the most advanced technologies. Okay? Since you are doing something out of the ordinary, you are not going to use standard techniques in order to get there. So those projects can be exciting, they can be scary as well. Okay? And for those projects, you really need close collaboration with your supervisor, because as you may be aware, most of the academics at the university are also researchers publishing in journals and international conferences. So we already do that kind of stuff, and if you want to join us, you are very welcome, but we need to work very closely because it's a very tough world. Okay. As I say, it's challenging, but it's also rewarding. Okay. There's been cases where the work of students has been presented at international conferences, where the work of students has been published in important journals. Obviously, adding that on your CV will really make a big difference. Okay? In particular, if you are interested in carrying your studies and doing research through, for example, a PhD, that type of topic is really what you are looking for. Again, research is not, in this context, about literature review. Okay? Is researching a topic that has never been researched before. You need to create some novel information in order to contribute, hopefully, to human knowledge. So here are some examples. So solving a problem that have never been solved before. Okay. Nowadays we are still dealing with registers. A very good research project would be, I take my mobile, I take a picture of all the students in the room, and automatically some face recognition software is going to annotate all your friendly faces and create automatically a register. Okay? It's not possible yet, but it's not science fiction either. There are software doing face recognition. There are software recognizing people. So by putting all together, adding a bit of extra knowledge, maybe we could do that. So that would be, for example, a very good research project if you are interested in image processing or artificial intelligence. Research is also about creating new algorithms or better algorithms. Okay? There's already a way of solving a problem using a given algorithm, but it's not fast enough, or it cannot handle a problem which is bigger than a certain size. So if you can come up with a solution providing a better algorithm, that would be also enter in the scope of those research projects. Also, research is about discovering new things. So we are, as you know, the internet is an endless source of data. So maybe we want to do some data mining, using all those data, or a subset, obviously, of those data that the internet is generating, and try to get some new knowledge out of those data. Okay? So there's a lot of IT needs, collecting all that information, formatting in the right format, and then there is some processing, which is again dealing with data mining and those very advanced techniques. Okay? So that could be another type of research project. Okay, so now that you have some understanding of what the final year project is about and the different types of projects there are, now let's look at how to get started. Okay? And as I said, it's very important to get started early. That's why I'm asking you to come here today. First of all, you need to think about what is the appropriate type of project for yourself. What is your strength first? Are you more of a build person, a design person, or do you really want to challenge yourself and go towards a research project? Or do you have an interest in research? So think about the topics. What makes you ticking, Where is your passion? Because with passion, you will work harder, better on your project. Obviously, those topics must be related with the topic of your course. As I said, if you are dealing with games, an e-commerce website wouldn't be an appropriate project. And then when you start having ideas, start speaking with lecturers. Okay, you have been here for 2 years already. You have already met many of my colleagues. Maybe you have already some good relationship with some of them. Go and see them and try test your ideas with them. They will tell you if there is potential for a project or if it's too big, too small, or not appropriate. So start the discussion. That's very important. And eventually, we would like you to select your ideal supervisor. Okay? Each of the academic in this school have some very specific expertise. Each of us is an expert in a given field. I'm an expert in pattern recognition applied to image processing and bioinformatics. If it's the kind of stuff you want to do, speak to me. I mean, there are other experts in image processing, like Professor Ellis, but speak to the right person, because if they are experts in their field, they are the ones who are most likely to push you, help you, and at the end you will get the best outcome out of your project. So for the build and the design project, the ideas in principle should be coming from you. Okay? What are your interests? What kind of clients maybe you could find? You have some of you will have made a placement, so they have already a close relationship with a company. They have an understanding of what are the problems they want to solve, and maybe that's the potential for a final year project. And you would have already a great client which will support you in your project. Then we are living as part of many networks, real and virtual. So you know hundreds and hundreds of people. Okay? Your contacts, family, friends, past, current employers, families who have a business, who have some interest in one thing or another, all those people could potentially provide you with a project idea. They could be your client. Okay? Then there is your interest. If you have a passion, you have been or every year there is a student who since the age of 14 have been dreaming of something. They've been dreaming of doing that thing. And the final year project is the opportunity to do it for real. Okay? So think about your passion. What are you really interested in? That may be the base of a final year project. Maybe there won't be a client, but maybe you will be so passionate about it that it will compensate with that, with the fact that you don't have a client. So here are some examples of what you may be interested in. Some of the lectures will also offer suggestions. Okay, some of us would like some work to be done, and we offer that as potential projects. Okay, so I will be publishing, sending you a list of projects that different people, different colleagues would be very happy to supervise. So have a look. Maybe you will find something of interest there. And if there is new projects coming, I will be updating you with those new projects. But as I said, having a client is usually a big plus. So that was about how to start a build or design project. For the research project is very different. Okay? In the research project, we want to compete with the best. We want to do something that nobody has done before. And us lecturers, experts in our field, we know exactly what are the limits of our field. We know how far we can go, and we know what are the hot topics. We know what the MIT is currently doing. And we know that they may have failed to see an opportunity there, and it's on that very niche project that we want to show what we can do. Okay? So on the research project, is unlikely that the project is going to come from you, because you don't have generally a good understanding of what are the limits of the science, of the knowledge in the different fields you may be interested in. So you will have a general topic of interest: e-commerce, medicine, image processing, gaming, or whatever. Approach supervisors who work research in that field and say, what could we do together? Okay? And eventually this colleague is going to tell you the hot topic in the field is that, and I think that using those techniques we could contribute to human knowledge. Okay? So for the research project, It really more depends on the academic who will be supporting. Okay. So the supervisor is a very important piece in your project. But you remember, in your project, you are the project manager. It's not the supervisor. You are the project manager. And the supervisor will guide you through the time of your project. So they will have the experience. All of us have already supervised tens and tens of projects. So we have some understanding about the complexity of a project. We will understand if what you are offering can be achieved during the time which is allocated to you, or if it's too small or too big. And your supervisor will be able to tell you, maybe you can cut that bit or extend it that way or another, or just tell you that's not an appropriate project, you need to think about something else. Okay? So it's very important for you to communicate with academics because they have this experience. It's the first time you are doing it, so it's unlikely you will have a good understanding about the amount of effort which will be required in a given project. Again, you are the project manager. The supervisor only offers advice. Okay? You follow them if you wish. Usually it's a good idea, but at the end of the day, you are the project manager. At the end of the day, the project is your responsibility. Okay? So the supervisor is a resource that you can use during your project. In reality, all members of academic staff are a resource because a project will need possibly several types of expertise. So at some point, your supervisor will tell you, I'm not an expert in that field, maybe you should speak to my colleague. So use all members of academic staff in order to get support if you need it. Okay, so as we said, the project is starting now, okay? And what we want to make sure is that during the summer, you already have someone to speak to, okay? So you can start thinking about the project, bringing ideas to make sure that when you are back at Kingston at the end of September, you have a clear idea about what you will be doing, okay? So for that reason, we want you to have a supervisor allocated as soon as possible. So until the end of June, we would like you to choose your supervisor, okay? So until the end of June, please approach academics with your ideas, and maybe they will be very enthusiastic about your ideas and say, yeah, I really want to do that with you. Let's work together. I will be your supervisor. Okay? So if by the 30th of June, an academic has agreed to be your supervisor, just tell me, and this academic will be allocated to you. Okay? If you do not, obviously some academics are really looked for, okay? Everybody wants that academic because he's very friendly and everything. So at some point they have to say no, even if the best projects are offered to them, okay? So try to be quick as well. If you don't get an academic by the 30th of June, at least suggest who would be a good supervisor for you. Because eventually we will allocate the supervisor randomly. Okay? So if you help us a bit in order to how to do the random choice, if you say, yeah, I would prefer that one. Yeah?
You know, like during June, July time, ain't most academics on holiday and stuff. Like
No, we are not.
No?
No. Unfortunately not. Yeah.
Are you
some of you have done some exams recently, so we will need a bit of time for marking them and do all those very exciting activity. So until the end of June, yeah, we will be around. Okay. I mean, sometimes we will not be in our office. Okay, we will be doing our marking at home or wherever. But you know, contact us by email, phone us, get an appointment, and we will see. Okay. Okay. So as I said, if you cannot get an agreement, if you haven't had the time, or if you didn't have an idea to offer to an academic, just provide a name, saying, yeah, I had this person as a lecturer, it worked well, I would like to work with them as a supervisor. We will not ensure that he or she is your supervisor, but we'll try our best. Okay. So, end of June is the deadline for giving us all that information. By mid-July, we will make sure that all of you will have a supervisor, hopefully your ideal supervisor, but if you didn't provide any information, you will get a supervisor anyway, who will be able to support you during the summer if you have queries or if you want help with your ideas. Okay. Obviously, during the summer, communication may be a bit slower, but there's more time. And we don't change supervisors. Okay. When you are getting professionals, IT professionals, and you have a contract with someone, and it's not professional at midterm to decide, no, I'm not doing that work with you anymore, with someone else. Okay. So we don't change supervisors, and the general rule of thumb is that you should see your supervisor at least once every couple of weeks. Yeah. Maybe at the start of the project, you will see your supervisor a bit more often, okay, when things are not quite settled. After a while, you will know exactly what you are doing, so maybe 3 weeks without seeing your supervisor will be something acceptable. And again, when we reach the end of the project, you are writing your very big thesis of 50 pages, having close collaboration with the supervisor is very important. Especially that the supervisor will be one of the 2 people who will be marking your thesis. Okay? So if your supervisor is happy with your thesis, it's already a good start. Yeah. So the deadlines. So today is this information session. So we have been filming this lecture. So it will be available on YouTube shortly. So I will be providing you the link. Okay. So for people who couldn't make it. Yeah, you missed it. Oh, by a year. Sorry about that. Next deadline, which is really important and you shouldn't miss it by a year, is end of June. Okay. We want your agreements. So an agreement is we are expecting the supervisor to be CC'd in your email, saying that they're happy with working with you. If there is no agreement, but you have a preference for someone, let us know. Otherwise, you will be allocated in a purely randomly manner. As I say, mid-July, we will let you know who your supervisor is. And on the 17th of October, we will be expecting your project proposal. Okay? So it means that if you don't do anything during the summer, it's going to be a very tight deadline. Okay? The proposal is just about ideas. Okay? You don't need to have done any analysis, not need to do any design, literature review, or implementation. It's just about having a clear idea about what the project is going to be about. To demonstrate that your project is feasible during the time frame of the final year project. Okay? So it means that all that conversation has taken place with your supervisor. Your supervisor has directed you. You know exactly what you will be offering to deliver at the end of the project. So if you are just coming back from holiday end of September, no idea about your final year project, it's going to be very tough to meet that deadline with a sensible proposal. Okay? So that's why we are starting early. Okay? And that proposal is 10% of the final mark. So the next deadline will be just before the Christmas break. Yeah, no, I told you it would be a tough module, but as I said, arguably it's the most important module you will be doing in Kingston. Okay? So just before the winter break, we're expecting you to demonstrate some kind of prototype about your project. Okay? To have a good understanding about where have you gone so far, because that's half of the time we have passed by that. Okay, so to make sure as well that you don't decide to only work on the project during the second teaching block.
How much is that deadline worth? Or is that all agreed for the prototype?
For the prototype is part of a mark which is worth 10%. And yeah.
Who do we submit to? Like, who do you give the work to?
Which work? So the prototypes, yeah, the proposal will be a small report. So you will be submitting with Turnitin. The prototype will be a live demo. So you will come with your laptop or show your website on a computer or your design. Okay. With your information will be provided on time, don't worry. There are some specific sections and you will know exactly what is expected. And then eventually the project deadline will be at the end of the second teaching block. Usually it's around the Easter break. Okay. 1 year is before Easter, 1 year is after Easter, depending where Easter is. Okay, any questions? It's not finished. That was the first part.
Right, I thought you were going to get away with it, Danny. Let me just suggest, because a number of the questions you already asked, I'm going to answer. So I'm going to try and I will do a slightly quicker presentation. And then following me, we've got a few of the academic staff to come and talk perhaps just about some specific sorts of projects in their area of interest, really to give you seeds for ideas rather than necessarily say, that's definitely what I want to do. So we've got about another half an hour at least to go. So if we can, let me do my bit. If you've got some general questions, do those, but any real questions leave till the end so that we can get through everybody that's coming along. Okay, so I'm Tim Ellis. I share the module leadership for this module with JC, but I mainly look after the staff side rather than the student side. So the reason why you've got JC's details is because he's the person that you will contact if you have any questions about the project and the way it runs that you can't get answered by your supervisor. So there's a certain amount of overlap between what JC has said and what I'm going to say, so I'm going to go through those much more quickly. So what you will have for your project is a module guide, same as you had for all other modules. And what I've done is to summarize some of the content of the module guide. Now I'm not aware that many people go away and closely study the module guide, so this is the first chance to really take you through what the expectations are on the project. And as it says, the aim is here that you can demonstrate both the skills and expertise you've got, and if you have it, some creativity in the project that you take on. And as JC said, the reason it's important is not just because it's a culmination of your studies, but because it is the principal document you'll take away with you, you can show to an employer. You write a 50 or 60 page report. We forever get employers telling us that students can't write good structured reports. And so we try and get you to write a good structured report and learn from that. And the best way you learn from that is to get some feedback on it, particularly if you can get early feedback. We are at the moment marking 20 reports each from last year's projects that were all submitted 3 weeks ago. We've just finished the project vivas. Some of them that I've been reading recently would really benefit from having had my feedback before they submitted it. But they didn't. They chose to submit it as it was. And sometimes they'll have a fairly poor report because they don't know how to structure it. So think about, as JC has said, making sure you use your supervisor. Develop your project management skills. I would say 75% of the project students I've had over the last, let's go 40 years, have said, I really wish I'd spent more time on my project. Now they say that at the end, because that's the time they can't do anything about it. So if you're interested in trying to do a good project, and I don't know anybody who's nobody's ever come to me and said, I don't want to do a good project, I have to get by with a minimum 40% pass mark. But if you want to do something successful, think about how you plan it out and spend the time on it. I heard you all laugh when JC said it's meant to be 300 hours, but actually that's what each module's meant to be. That in the self-study time you have, you're meant to spend that amount of time per module. And on the project, it's pretty well all self-study. We have a few project lectures, but all the time is the time you put into it. If you don't put in 10 hours a week, 1 week, then you need to put in more the next week, or you will come up short. We know what our understanding and expectations are of a project, and if you don't meet them, you don't get as good a mark. So it's all about your expectations and how we can support you in that, and that's what we'll try and do. So you're looking to develop those skills and demonstrate how you've learned those skills. The learning outcomes that you can plan and manage, that you can investigate and analyse a problem, that you can apply relevant techniques in a systematic way, that you can construct and present a prototype that leads to a suitable solution with testing and evaluation, and that you can write an effective report that tells somebody else that's not involved in it why you did something and how you did it and what the outcomes were. So that's what the project is about, you developing those skills and to demonstrate some competency in being able to construct that report. Okay, so this is why people fail. This isn't anything that was new to you. You all had coursework deadlines in the past, and I'm sure some of you have been very successful at meeting them, and some of you have been very successful at failing them. And it's usually because of poor time management. It's usually because you leave it too late to do it, and you haven't understood the scale of the work that you've got to do. That's just to reiterate what JC said. If you work out a program of work and you don't get 10 hours in 1 week, I always tell the students, well, where are you going to make that up? How do you get back to getting online and on track with the amount of time you put in? Develop a work plan and stick to it. That's one aspect of the proposal document, that you have a work plan. Develop contingencies. A work plan means that sometimes things go wrong. You get a cold and you're off for a week or 2 weeks. Heaven forbid, somebody in your family is unwell themselves and you have to look after them, or you have to go to a funeral. There's a whole set of things. But part of project planning is understanding what a contingency is and how you build it in. So those are all part of the skills you're trying to pick up. The other reason projects often fail is because students don't go and get advice. And the one excuse is the wrong word. The one reason I hear for that is they say, well, I haven't done anything since the last time we met. Well, actually, that's the best reason for going and seeing your supervisor. To let them give you some support and say, well, what is it you should be doing? It is true to say if week by week you go along and say, well, I haven't done anything, I haven't done anything, I still haven't done anything, I still haven't done anything. There's not much they can do if they're giving you advice and you're not using it. But try and keep in contact with your supervisor. They really are trying to help you complete your project successfully. Twice a week, twice a month, as JC said. Okay, lots of places where you can get advice, your supervisor. As JC has said, all members of academic staff are available to you to go and ask if you've got specific technical problems. And some of the technical staff are equally able to give you good advice on how you do things. This is my little graphic, so you can bear with me as we go through this, but your project is a journey. It should be, on you understanding, exploring things. So you start out at some base camp, and what you're trying to do is get to the peak of your academic achievement, and you've got to plot out your path to do that in. And you've got to understand what the milestones are along the way that will allow you to understand when you've reached some definable waypoint in your project. So the staff are here to help you, but they're not here to carry your load. We're not your porters. We're here to advise you on how you can do things well. So make use of us as you will, but if you decide not to see your supervisor over the whole year, don't count that as our fault. That's still down to you. That's part of what you have to do to manage your project. You all know what plagiarism is. I'm expected to provide. You don't? Ah, okay. Shall I go through this in much more detail?
We don't. Yeah, you can keep them back on his own.
I think you know it. I'm required to put it up there. And it's particularly true on the project, because people think, actually, that bit of text on the internet explains much better what I want to say about this aspect of my project. I'll just cut and paste that and put it in. Well, you all know how Turnitin works. We still get people that submit projects that are 60% off the internet. How would you even contemplate that that was a sensible thing to do when you can actually submit your stuff to Turnitin and it comes back and tells you what's yours and what's somebody else's? So make sure you don't lose sight of what actually it is and what the consequences are if you don't succeed. But at this stage, in the final year of your course, you can be thrown off the course if it's more than your first offence. So, bear it in mind. These are all the things that JC went through, so I'm not going to linger on them, but that's what we're trying to do. When we get to the end of the project, we are going to assess you on whether you've demonstrated your understanding of those skills and those capabilities. So you can do a project which is just to generate a single web page with one picture in it and a few words. And that's fine. We can mark that. That's probably worth a good 6 or 7% over the whole project.
Yes.
But it doesn't get you a pass mark. So you've got to have a project which is sufficiently challenging so that you can use all your skills on it. If you don't have any skills, then 6 or 7% is what it's going to be worth. But the aim is to be able to say, this is how well I can do at this. And that's what we want to mark. We want to mark people that have got and can demonstrate those skills. So that's what it's about. How do I start? We've already had this from JC. I always say to people, it's what you're interested in. As JC has said, it's about what you've got a passion about, that I would choose as the main way of picking a project. And again, if you can't think what that is, go and talk to your supervisor or another member of academic staff. We're used to digging out of students what their interests are and suggesting to them the sorts of things they can do as projects. We do it every year, and some of us have done it for many years. Hey, Paolo. Okay. And then, of course, the first focus will be on the proposal. It's about between 1,500 and 3,000 words. So it's not just a half a side of A4. You have to put your ideas down, your understanding of what you're going to do, and some sort of project plan, so that you can understand when you're working and operating to that plan, or whether you're getting behind schedule. So we've already had that from JC. And you've already had that from JC, and I would have no shame in showing it more than once, in bold, in red, in whatever type it needs for you to understand it is your project. Okay, you've had that from JC, so how you start a project, if you don't have ideas, talk to other people and see what things you might be able to solve for them. And finally, I would take this as almost the last option. You know, if you can't think of anything, then choose one of the possible projects from the staff. There won't be a huge number of them. What have we got in here? 150 people. We've probably got 12 or 15 projects available. So if you are really interested in one of those, jump on them quickly. But I still think most of them should come from the top of this list. Things you're interested in and a bit passionate about. We've been through that. Your role, all the things that JC told you about, attending meetings, keeping notes about meetings so that you know what it is that you've agreed to do. We run a set of project lectures. Last year we videoed them all. Some of the videos we'll be making available this year, and we'll be putting some new things in. So if you've got any ideas of what you think you might want in terms of support during the year, let me know, and we'll try and arrange a project lecture on it if you're unsure of some of the things that you've done in your course. Make sure you observe deadlines. And JC emphasised this idea that what you're producing is a professional output, but it's also about how you develop your own professional skills and behaviours. How you use your supervisor is part of that. How you make sure when you make appointments and meetings with them that you turn up, and if you really, really can't turn up, you let them know. Because that's how it works in the professional world. We don't just treat people as though they're there all the time and we'll pop in or not pop in as we feel like it. So try and build and develop your own professional behaviours as you go through the project, because it's the one module where you are expected and can do all of those things. Role of your supervisor, to be available and guide you through the project, to be there for regular meetings, not to arrange them, that's down to you. Try and make those regular enough. Advise you on how to tackle it. Respond to your other types of requests. It may be by emails. Advise on when they're available, because they're not always available. Academics go away for academic conferences and other types of meetings during the year. So you can't just turn up and say, well, I came on Wednesday, you just weren't there. You have to arrange these things. That's what meetings means. And they will help you monitor your progress and review against your project timetable, because that's an important aspect of the project and how you undertake it. And then these are make sure regular meetings, feedback. JC's already said we don't change supervisors. Okay. So we have 2 markers for a project. Your supervisor is 1 marker. There is a randomly selected second marker who will then also mark your project. And in fact, they see both your project and your Viva demo. And we'll come on to that in a moment. You can get feedback from your supervisor. You can get feedback from draft proposals, as long as you give them to somebody to look at. And we also provide feedback via an online information system that Pushbar over there has developed over the last couple of years. And you'll all get a login for that to allow you to see what the current feedback on each one of your project milestones is. Okay. So as JC said, we've got 3 different types of projects. They have different marking schemes associated with them. We can see that for the build and design projects, we have 4 principal elements, which are at 10, 10, 70 and 10% each. So you can see the final report covers the largest proportion. But remember, that's not just the report. That's actually the whole of the project that you do. And how you report on it and how you present it are all just part of that. The research projects are only slightly different. The report itself the final report is at 60%, and they do a presentation, a 30-minute presentation with 30 minutes of questions. So there is a longer Viva associated with the research projects, because they have to present their research ideas in a proper presentation. So as it says, the proposal about 1,500 to 3,000 words, early prototype demo, the report between 12 and 18,000 words, and either a 30 or a 60-minute Viva at the end of the academic year, at the end of TV2. So the project report for the build projects, this is how it breaks down inside. So this is the sort of guidance somebody was asking for earlier. These are the elements we mark it on. So where we look at your introduction and you're expected to do some sort of literature review, then we mark it on how well you understand and present the background, how you motivate it, how you identify your aims and objectives, what your deliverables you expect will be. Whether you've looked at competing systems, other technologies and other platforms that you're looking to implement on. That you've done a clear analysis of the problem. I read so many reports where they start out at the beginning of the analysis section saying, these are my requirements. That goes at the end of your analysis section after you've done the analysis, not at the beginning of it. So there's a logical structure to the way that you go through and present and then analyse a problem. The design side of it at 20%, implementation is 30%, what libraries you use, how you construct the code, then how you test it and how you evaluate it. So this is a fairly comprehensive set of, these are the things we are looking to find the skill set for in marking a build project. Design projects got obviously some similar elements to it. There's a larger mark for the background and literature review. That really is about reviewing what's in the literature on the design issues. An analysis, the design itself, there is still an implementation. A design project doesn't have no implementation, but it has less of an implementation than a build project. And then finally some testing and usability analysis at the end. They're all key elements to understanding and building, say, a simple prototype system. Research project is rather different, because what you have to come up with is both a research aim, a hypothesis, and then a way of proving or disproving that hypothesis. So usually some sort of experiment. You're going to need some data to work with. You're going to do some analysis of that data, and you're then going to present the results in some logical fashion that shows an understanding of how you've actually tackled the problem and how far you've got with the problem. So this is much more the breakdown of a research project. lots of places, lots of sources for information, so I'm not even going to linger on those because they're all fairly obvious and straightforward. We can get rid of this thing, we hope. The module guide, much of this comes out of the module guide. That will be available on Studyspace, of course, when the module is set up, when you get back. We run a set of as I say, of project lectures. This was the program from last year, and as I say, I formulated it as what's called a how-to guide. So the idea was to go through and try and get the ordering it right so that we did the right things in the right order. So the first lecture talks about the proposal and goes through some of the other issues around how the project is managed. Graham Jones then does one on how you should manage your project and how you should manage your project supervisor. Some of the other technical ones, as I say, because we video recorded them, we may reuse that material, and so we've got some slots to put some other ones in if necessary. And then towards the end of the project, we have some on how you go about writing up your final report and how you prepare for your Viva. Okay? So you'll all be very aware of how to fail things, I'm sure. But I like to put my own set down here just to finish off with. So don't meet any of the deadlines. That's a good way of getting very poor marks. Don't meet with your supervisor. And I found that quite a successful one in the past. Not universally successful. Some people actually do a good project without seeing their supervisor very much. But the majority don't do that. In general, you're not going to have a good project if you don't get good advice on it. Leave all your work to the last minute. Well, that one you do know. I don't need to explain that one to you. Copy your project from somewhere else. That one works well at failing your project. I had a couple of those in the last few years. And there we are. Ignore the project guidelines. All the stuff we've been telling you is all irrelevant. In one ear, out the other. You can make no mistakes then. Failure is a definite outcome. Oh, don't plan it. There we go. So those are my suggestions of how you really have an unsuccessful project. So I hope you take those on board. And we'll know in a year's time how well that works out. Because when we mark them, we'll say, wow, they really took this one on board. I wish I'd been able to take the earlier ones on board. Okay? Fine. I'm going to pass you over to Pushpa, and then Paolo, and then Paul, just to talk a little bit about the sorts of projects in different areas within the Kingston repertoire. Sorry? No, this one's mine.
No. Okay. One of the stories behind me is I used to study here. I did my undergraduate here, and I did my PhD here, and I'm stuck here for like 12 years now.
I'm not going to tell it to you.
No. The reason I mention it, my final year project truly defined my career. Because of the final year project, I decided to do my research, and I ended up here teaching you guys now. One of the things I always like to ask you is try to interpret the definition of education. What is education? If I ask that question, what are you going to say? Learning stuff. Very good. Anything else? Sorry? If you do some research about the origin of the term, there is a Latin term behind it. I don't know any Latin, but I like to believe that's the correct the root for this word. There is a term called educators and edusia. What that means is a toolbox. So what you are doing in your undergraduate life essentially is trying to build your toolbox, identifying your tools, put them in a box, and carry with you everywhere you go. So you should be able to collect some tools so that you can use them. Not only that, you should be able to identify which places you can use that particular tool. Okay? So if you remember all the things you learned in your undergraduate, you are learning in the undergraduate, you learned in your primary school, junior school, it's all about somehow getting some sort of a toolbox set up so that you can carry with you. So the final year project is quite crucial because this is probably the last chance you get to have a look at your toolbox, prepare it, and make sure it's nicely there for you to help with your life beyond the graduation. And in the undergraduate project, you can probably learn stuff, do mistakes, and learn from the mistakes. But after graduation, you might not probably get any chances to learn from the mistakes because you might get fired. Okay? So try to make the best use of this whole experience. It's a year-long experience. You'll be having a nice time with your supervisor, learning things, exploring new topics. my area is probably to introduce a little bit more into the information system projects. Now tell me, or who can tell me the definition, or try to come up with something. It doesn't matter how silly sounding it is. What is a system? We have systems inside our body. We have our cardiovascular system. We have our respiratory system. Very good. It does some sort of they are doing some sort of set of functions. What else?
An organization of modules that work together to achieve a great system.
Exactly. You already got 10 marks for your. If you're going to do my model, you already got 10 marks.
Whoa.
So a system is number of components working together to achieve a common objective. Okay, so there are components and they are like coordinating each other and try to come up with the final outcome. So there are two ways looking at this. I mean, you can look at it as a software engineer. So Paolo will be covering that part and Paul will be covering about that part. Or you can look at the designing side of things. So core differences, if you think about the software engineers' way of looking at it, they will be looking at the theories, methods, tools, and the process behind the development of it. So it could be a quite systematic process of coming up with a nicely done set of units and program codes and libraries and interfaces. Whereas the information system side of it will be a little bit more into the more emphasis onto the social context. So social in the sense how people are depending on this system, how people might be rejecting this system or accepting this system. So if you are especially in the information system route of courses, you might be more interested in exploring this societal or social aspect of it. Okay? In the final year also you'll be covering so many things about this aspect in various modules, about how to identify people's needs, how to prioritize them, and how to put that into some sort of a package in your system. And one of the key things is most of the information systems do fail, unfortunately, still they do. And the reason behind that is not identifying the actual needs and requirements of the users. So one of the things you might explore further is things like agile development, where you try to involve your customer, get their feedback constantly and keep developing it rather than surprising them with a final solution which they might reject in most of the cases. So as an information system design student, or if you are looking forward to do a design project, you will be having more concerns about how the different people aspects of these things are playing a part. So this is just a list of jobs you might do if you are interested in the information system side. So they are the people who come up with the design of the solution, whereas the developer might try to translate that into some sort of product that has buttons, that has something that you can double click, or that has some sort of functions. So what I'm trying to say, emphasize there is focus on the things that you enjoy doing, because naturally finally it will be quite stressful. There will be so many deadlines and feel like, okay, I have to get my 2.2 or 2.1 or not 2.2. Don't try to get a 2.2, try to get first class. First class or your second upper, and you'll be working very hard towards it, and you'll be quite concerned about the deadlines, the amount of words you have to write. So it is quite essential, as Tim said, pick something that you are going to enjoy doing. Okay, when it's something enjoyable, you'll have quite lovely time, you'll explore so many different topics, and you'll probably come up with a very nice product as well. So those are the roles you might be going into if you're doing an information system project, and then a definition of a system and an information system. So system I meant to ask it that as a question. You probably have come across the term SDLC, System Development Life Cycle. Yeah? Probably in the first year with Jeremy, or in the second year as well. What do you do there? You first try to understand what needs to be done. Then you systematically come up with a set of designs, analyze it, design it, develop it, test it. You keep monitoring it. So as an information system designer or an analyst, you'll be trying to understand the requirement, then come up with a set of plans to meet that requirement, build something or design something, and then check whether have I done something correctly? Have I done it correctly? Have I done it in the correct way? So in your design project, you'll be covering loads of topics to do with that. And if you go back to the marking criteria, that's why you're having 20% compared to the build project for the introduction and literature review, and then the analysis and methodology and the design sections. You are getting more marks for that. What that means is you need to do more tasks in a very people-oriented, society-oriented way, come up with show enough evidence that we have skills to understand the requirement and come up with a quite fit for purpose design. Okay? And if we move forward about specific task you would be doing, so in the analysis and methodology will be probably try to discover the reasons behind this demand. So you'll be using variety of tools. You may not use all these tools. You might be probably exposed to these during your information. No, you'll be exposed to these more in your information system and strategy modules, but you might have come across these in your IPM module, information and project management. Yep. Yes. Anyway, you'll be using this kind of range of tools to understand what is the problem, what are the things that needs improving, and how can we improve them. Then based on that, those outcomes, you'll be coming up with a design so that the design is comprehensive enough to understand or to solve the problem that you are trying to deal with. So if you are doing a build project, you'll be doing all those tasks, but little bit of in less detail in terms of the thoroughness of the research you are doing, and you'll be coming up with a number of design iterations about wireframe models and much more improved low fidelity and high fidelity wireframe models. And then finally, some people might think I don't have to write a single line of code if I'm doing a design project. I'm an information system student. Okay, you can probably get a pass with that, but the thing is, if you have tried yourself coding something, because humans are naturally quite good programmers, because humans are in this stage because they try to analyze different situations and come up with quite innovative answers. So probably if you are one of those people who say, I hate programming, please give it a go. There are so many wonderful things that you might enjoy, because for example, debugging is a quite wonderful thing. Most people hate error messages, but it's a wonderful thing if you try to deal with that and come up with some solutions to get rid of an error message. If you are doing a design project, don't try to come up with a set of PowerPoint slides saying this is my design prototype. Try to code something. Try to make some sort of an interactive prototype. Okay, it's not a hugely difficult thing. Just spend one weekend, watch some YouTube videos, and you can probably code something. Okay, you can pass it with paper prototypes or PowerPoint slides, but try to get a good A grade with something interactive, because at the end you'll be quite proud of that experience, that you have had the experience of programming something. Okay. Now I had one of my design students who pretty much did an amazing prototype. He hasn't touched a single line of code, but he developed a fully working system for a school, and it's fully working actually. Even he was surprised about the ability of his programming skills. Okay. So few things to take home. If you hate programming, do an IES project. If you hate programming but still you love designing, still do an IES project. The core message is an IES project means you'll be analyzing a lot of things about the background, the need, and coming up with a solution and try to justify the solution. Okay? It's not a way out of programming. It could be, in a way, think about it as you're trying to focus on things that you'd love doing. So if you're somebody who loves doing research and justifying your findings and coming up with nice diagrams, design project would be something ideal for you guys. Any questions so far? How many of you have decided which way to go, or not yet? Okay, I'm going to stop you there. What I would like you to do is just focus on the fact that supervisor and you and supervisor relationship is quite important and influential. So try to enjoy it, and also try to pick a topic that you are going to enjoy doing. Okay, thank you very much.
Okay, if you don't like programming, don't do anything with me. Okay, so let me give you my name. Can I write here? Yeah. Okay, so my name is Pavel. Doesn't matter if you don't know, you cannot pronounce my surname. And I'm the leader of the robot vision team. Okay, so essentially we do image and video interpretation. So any photograph you take, we try to solve the problem of trying to understand what's in the picture, what's in the photograph, and maybe put together similar photographs. And I can show you a research project done by a student who just finished, Mali Coxon. You can actually check it yourself. If you go on the blog here, you'll see an explanation of what his project was about. Essentially, he was asking the crowd, so the internet, to draw something that looked like a picture that he was uploading. So, for instance, he was uploading this, and he was asking the internet to submit pictures that look like that. Okay, and then he developed an algorithm that could make similar pictures closer together, right? So he had what we call clustering. Okay, so this 2 by 2, this image essentially represents all the pictures that were submitted to the server that he made available, and they were clustered in a corner if that corner represented a specific drawing that was similar to all the other drawings which are in that corner itself. Okay, so there are many pictures here. In this specific case, I think he asked the crowd, so the internet, to submit pictures on representing, I can't remember, I cannot see here at the moment, but there was a bed, a desktop, an animal, the earth. And the idea was basically to develop an algorithm that could put things which are similar together, all right? So in our team, we are interested in doing similar things with video as well. So if you take video clips, the idea is basically to understand what the video clip is for or about, okay? So extracting the salient features of that in each frame of that video clip. So this is what I'm interested in. Now, what I was asked to do was actually to cover something on games. We have, as you probably know, we have a course of studies on games, computer games. And what we do there, we teach students how to code specific games that contain intelligent avatars or characters, as you call them now, or AI, which means artificial intelligence characters. And in those games, usually you have interactivity, so high interactivity. So it could be a single player, multiplayer game, okay. And the idea there is to develop a game that challenges the user by fighting against the user. It could be a first-person shooter game. It could be a board game. Not many people do board games anymore, but there have been some in the past. It could be just an environment where different cultures thrive, and then basically you look after one of them, and then maybe you start a fight with others. You must have seen that in computer games available on smartphones, smart devices, and desktops. Okay. Essentially, there's something there's a kind of similarity between the two things, which is artificial intelligence. So we're trying to make computers intelligent, okay, by developing intelligent algorithms. So if you're interested in that, then you can come and see me, all right? I don't have anything else to say. Martin, your turn.
afternoon, everyone. My name's Martin Tunnicliffe. I've been asked to say a few words about networking projects and also about security and forensics, since Demetrius Sapsinas, who would normally be teaching this, telling you about this, isn't available. I'll just write my name down, like Paolo did. Yeah. Right. Okay. Networking projects. A lot of people like to put themselves in the position of a network manager or a network designer, network consultant, and produce a network or a network upgrade for a client, either a real client or possibly a made-up client if there's no real client available. This is a screenshot from one of our current projects. This is a designed network implemented virtually in a software called Packet Tracer, which you may have heard of or used possibly in some of your modules so far. This allows you to create networks, to configure them, to test them, as though you were using the actual hardware components. So you have to go through all the interfaces that you would if you were really setting them up. And you can choose your components, you choose what's the best component for particular uses, making sure that the connectivity is all there, doing your DNS and your DHCP and all the rest of it, and getting the servers to work and all the rest, to fit a client's specification. That's one kind of simulation tool which we have. Another kind of simulation tool we have available is OpNet, which doesn't mimic the real configuration quite so well, but it gives you a lot of performance statistics which you can use to determine how well your network design is performing under load. And there's other software, there's other tools available. There's GNS2, there's NS3, there's something called OmNet. There's a lot of tools you can download from the internet and use. But these are two we particularly support in the faculty. Another sort of network project you might do is, rather than the more prosaic using existing technology and doing something with it, is to investigate something novel, a novel networking topology, a new protocol which is being investigated. To study the literature, to perhaps perform some simulations on it using MATLAB or something like that, and to produce recommendations for perhaps new applications of that technology, for its use in particular environments, for possible future developments. This would be an example of what we call a research project rather than a design or an implementation project. Anyway, so much for networking. Security, I'm getting into Demetrius' slides now. Security is basically to do with the protection of information and its critical elements, including systems and hardware that use, store, and transmit information. And we have a lot of projects in that area as well. One particular area, this is more Demetrius than me, is to do with forensics, which is to do with uncovering and interpreting electronic data, with a view to doing two things, which can somewhat work against each other. Firstly, preserving evidence in its most original form, while at the same time performing structured investigation by collecting, identifying and validating data for the purpose of reconstructing past events. So you need to investigate the data, the information, while at the same time not compromising its integrity, which may be required for legal purposes. Typical security in a project. Firstly, there's secure programming. One advantage we have here is storing passwords in char arrays and then zeroing them out after they're used, after they've been used, so they're no longer lying around in memory. Defensive programming. One example is using assertions. Assertions, you may know, are conditions, Boolean predicates, which should, if everything's going well, return a true value, and a false value would indicate, that something has gone awry. So good use of these assertions can protect software from and identify when it's going wrong, when there has been security issues. Databases as well, identifying which users should have access to particular schemas and objects and making sure that only those users have access to them. Encryption of passwords in client-server and server-server connections. Also, of course, storing not plain text passwords, but encrypted passwords on databases, and hopefully, perhaps with a bit of extra random information added to them as well, to make them harder to crack. This is what's known as salting passwords. Web applications, checking unvalidated input. One particular reason why web applications can be easily compromised is because the input to them through forms isn't properly validated. Very often you can do what's called an SQL injection attack, whereby you can enter code into you can enter SQL code into a web application, which will then be passed on to the database and cause the database to return some piece of information which it shouldn't do. So there's quite a lot of interesting work to be done in validating form inputs to make sure that sort of thing doesn't happen. And here are some examples of project areas where that have been done in the past to do with forensics and security. Analysis and evaluation of the Windows event log for forensic purposes. Botnet analysis and detection systems. Botnets are malware objects which reside on infected computers and essentially communicate with each other and with the person who deployed them, usually for the purpose of doing what's called a distributed denial of service attack. Detecting whether or not you've got bots on your computer or whether you have a botnet deployed across a network is quite an interesting area for study. Information hiding using audio stenography. Steganography. I always say stenography for something reason. I always mean steganography. This is basically hiding information inside other information. Messages can sometimes be hidden inside images or inside audio files or inside text files. And there's two quite interesting sort of aspects to this. Making algorithms which hide the information well, and of course on the other side, finding ways of detecting information which is hidden inside files and finding out what that information is. Digital image forensics, of course, is connected with this. Advanced captures. These are things which are used to detect whether or not a person entering information into a web form is a real person, or whether they're a program or a computer or a robot doing it, masquerading as a person. I'm sure you've seen these similar sorts of things. You've got a bit of rather distorted text in a JPEG file, and you have to type in what it is. Voice over IP security. Security analysis of wearable fitness devices. These are wearable devices which monitor exercise. Image encryption using the AES algorithm. The AES algorithm is an advanced symmetric encryption algorithm. It uses blocks of 64 bits. It's very, very, very difficult to crack, but of course, you know, we're always looking at new ways of deploying it for different sorts of encrypting different sorts of data. Testing web-based password recovery protocols. We've just finished actually a project on that, which was aimed at improving the security of the password recovery protocols we have here in the university, and that was actually quite a good project. So yes, that's an interesting area you can possibly work on as well. Anyway, that takes me to just about to the end. Yes, it does. Any questions? Right. Okay. Thank you very much.
Just one more to do.
You're going to miss the best bit. Who remembers that desktop background? Okay. Do I really need to put my name on it? Yes. Okay. So my task today is to talk to you about software engineering projects. Warning, contains programming. Okay. And the reality is pretty much every project, okay, maybe if you're doing a networking project, maybe there won't be so much programming. But the reality is I would gamble that 80%, 90% of final year projects in this school are going to contain programming in some way, shape or form. Well, if you end up thinking, oh, I'm going to do an IS project, I'm going to do a software engineering project, I'm going to do design, I'm going to do a build, right? Unless you're doing some abstract piece of research, which is what you might do, and I've seen some very good projects fitting that description, but by and large, pretty much every project that we see come through our doors, with one or two exceptions, is going to involve some form of programming. So what makes a software engineering project different? I'll start at the end, okay? So a software engineering project usually results in some software artifact coming out. You write a web application to run a phishing website, which is one of the ones I had this year, or a collaborative music jamming application, or any number of pieces of software that come out of a process, a project. A software artifact emerges at the end. Now look around this room, right, and I'm not going to point at anyone, right, except him, or him, right, or any number of other decent programmers. Some of the actual usual suspects, I don't say, or him, or any number of decent programmers around here, right, thinking, you know what? I'm just going to do a software engineering project. I'll disappear into my bedroom for about 2 months. I'll rattle out this awesome, all singing, all dancing bit of software, and then I'll bowl up along to graduation and get my first. Yeah? I'm afraid it don't work like that, okay? You don't get to barricade yourself in your bedroom with NetBeans for a few months and then bask in your first class degree. It's actually about the journey. The final year project is an academic piece of work. And Tim, when I came in, I heard Tim was telling you about the mark distribution. Right? I always tell my final year projects that a huge amount of the marks is for the academic work. What you write about, the report, how you present the report, the process, what goes into that piece of software emerging at the end. It's about the journey. So a good software engineering project will involve, and by proxy, right, most computing projects that happen in this school will involve a degree of research. They're all research projects to some degree, right? Because you don't just sit down and rattle out a bit of code and then hand it in at the end, right? A good project will involve research, not just a technology. Oh, I'm going to use this bit of software or that bit of software. I'm going to use this framework or that framework. You also look into the wider context. You need to look into the wider context of your project. Where might your project fit into an organisation, a subject area, society as a whole? You'll be asked to do this thing called a literature review, which you'll all be thinking, what's a literature review? You've never been taught how to do one of them, but this is where this comes in, okay? You'll need to look at what work has been done before. What can you learn from it? What's worked well in the past and what's worked badly? This research will feed into your project. It will have an influence on your project. Okay? Don't look for just look for systems that do exactly the same thing as yours. So if you were doing some, e-commerce site, if you were selling sprockets, I don't know what a sprocket is, but let's say you were selling sprockets. Don't just look for other systems that do the same thing. If you're selling, if you're doing e-commerce, don't just look at Amazon and eBay. Don't look at the usual suspects. Look for things a little outside of the context that you can learn from that might have some commonalities with what you're doing. Okay? Don't rule out existing systems that are not computer-based. Okay? Remember, it is an academic piece of work. So when I say look at what work's been done before, don't just look at technology, but look at theory as well. And all this happens before you write a single line of code. Arguably before you do a single bit of technical design. Okay? A good software engineering project will involve analysis. And I've put requirements in brackets before that at word analysis. And Tim talked about this earlier on as I came in. I heard him say about how many projects he's seen where, you open up the analysis section and it says, here is my list of requirements. This requirement is a must-have. This requirement is a should-have. And this requirement is a could-have. I use Moscow, aren't I awesome? And then I will ask them, right, when I do their Viva, where did you get these requirements from? And they go, and usually the answer is, not that they articulate this, but usually the answer is, they pulled these requirements out of their backside. Okay? We want you to engage in requirements analysis. Analyse the requirements. Define the problem you're proposing to solve. Right? And we expect to see formal methods to do this. Right? We expect, ideally, if you can, right? I always try to encourage people to try and do a project for a real person or company, not for their imaginary friend. Okay? It's not always possible, I know. But if there is a real person, or you can co-opt real people to be your users, to be your clients, my experience is that software projects go so much better because then your users keep you honest. They can feed into your requirements gathering process. So when I ask in the Viva, when I'm giving you a hard time, where did these requirements come from? You can point to some kind of formal process. Oh, we had a kick-off meeting and we got an initial list of requirements, and then I produced wireframes and I showed these wireframes to the end users, and then we went into an iterative development cycle, and so on and so forth. Okay? It's about the journey. Always remember that. Software engineering, requirements analysis might involve identifying what could go wrong. And you will be taught tools how to mitigate against these, like SWOT and PESTLE. But I often see projects where final year project students seem to think that everything we ever teach them has got to be in the project. Okay? It's like we teach you how to use a tool set. So it's got a hammer, and it's got a screwdriver, and it's got a drill in it, right? And we give you a task, which is put baby to bed, and you say, well, I've got to use all them tools they've given me. Let me go, can I use the drill and the hammer for this task? Okay? Use the tools that are appropriate. So if a SWOT analysis is not appropriate for context, don't use it. Don't just put a gratuitous SWOT analysis in there. Okay? But use the tools appropriately to engage in your analysis. We do expect to see not only that you know how to use these things, but that you know when to use these things. Okay? Fitting on from that, don't just pluck requirements out of your backside. Okay? There does need to be a clear journey from A to B. Now, maybe you don't have users. Maybe you couldn't get a client. Maybe you are doing it for your imaginary friend. That's fair enough if that's how it pans out. So your requirements still have to come from somewhere. They can't just come out of your backside. Okay? They might then come from analysis of the literature. So you've looked at similar systems, and as a result of looking at the similar systems, you've identified certain core functions that all of them have to have. Okay? Okay, let's, I don't want to use up all your time. Project management. A good software engineering project involves project management. It is, again, part of a tool set that you get taught. Most of you have probably just finished, I think all of you have just finished a project, module called Projects and Their Management. Okay, so you've got the tools in your tool chest to use this. Okay, but use the right tool for the job. Don't just say Agile because you heard one of us lot use it. Okay? The amount of times I see a final year project that says, I am going to use the Agile methodology. There's no such thing as the Agile methodology. There are many Agile methodologies that you may choose to use if they are appropriate. And being able to demonstrate you know why they're appropriate as part and parcel of this, of what you're going to write about and what you're going to show to us to demonstrate your knowledge. Okay? You don't have to use Agile. There might be a good reason why an Agile approach is not appropriate for your project. And that is fine. You discuss that in your reports, and you cite appropriate literature, and you demonstrate that you know you can talk about why you've made the decisions that go to back up your project. We haven't written a line of code yet. Okay? I've seen so many projects do badly because all they've done is written a big chunk of code. That's not what this is about. It's an academic piece of work. Oh, that last one. Yeah, don't say you're using Agile because it's a buzzword and then clearly not use it whatsoever. Oh, I use the Agile methodology. Well, aside from that, there's no such thing as the Agile methodology. Where were your time boxes? Where were your sprints? What? Huh? What? No, I just sat down in my bedroom and wrote this program. Design, okay? And Pushpa talked a bit about this. Whether you go information systems, whether you go software engineering, they're pretty much the same, right? At the end of the day, perhaps you will be assessed more on your ability to design. If you go for a design project, you'll be assessed on your ability to implement the work. If you go for a build project, okay? A design project is not a bit of software engineering without an implementation. It's not, okay? A software engineering build project is not I'm a bit rubbish at writing, but I'm absolutely expletive hot at programming. So I will just go ahead and write a great application and I'll hand in 6 pages of report and I'll do awesome, okay? It's just a slight difference in the grade bandings, allowing people to excel in their areas where they are most skilled, okay? But all the fundamental structure of a project, unless you're going down the research angle, are the same. We will expect to see a design in a build, a software engineering project, okay? It's about modelling your application. Explain your models. Don't just shove a diagram in your document and think, done, okay? Amount of projects I've just seen where a you know, class diagram or, you know, use case diagram just appears out of nowhere. Bang! Suddenly, diagram. And then finally, you get to the implementation. Okay? And depending what methodology you're using, depending what practices, project management methodology you're using, right, you'll go about this in different ways. You might be doing this iteratively. So in time boxes, develop, show your user, develop, show your users feed into your process. Okay? But you shouldn't start implementing anything until you've got all the previous things done. And every bloody year it's the same. You know, at least 2 or 3 people out of a group of, I don't know, 20 people, project students, think, you know what, I can fake the documentation after the event. I will just write the application and not listen to a word either Paul or my supervisor said, and I will just rattle out the documentation at the end, right? It never works. It's about the journey. You can't jump to the end of the journey and then go backwards. Okay? Testing and evaluation. And so many people forget there are 2 streams to this. There is the basic software testing. Black box testing, does the thing operate in a bug-free way? Is it efficient and so on? But what people often miss, right, is user testing. Is the application a success? It might be completely bug-free, but you give it to the end user in the context it was originally intended for, and it can't fulfill the purpose for which it was written. The end user decides to go back to the old system, or they bypass the new system because it doesn't give them everything they want. So there's 2 strands to testing. The actual, testing from a software point of view and testing from a user-facing, user experience to some degree, but there are other aspects of that as well. Try to involve real people in that. Okay? Don't just put a table at the back of your document saying, feature XYZ. Yeah. Explain why. Explain how you got to that. Yeah. Okay? Okay. The $6 million question. Should you do a software engineering project? No. No. Who thinks they're going to write some code as part of their final year project? Right. Okay, let's do that the other way around. Who thinks they're not going to write any code for their final year project? All by yourself. Should you do a software engineering project? Of course you should. It's the pinnacle of everything you've been working for here. And you can dress it up by saying, oh, well, I'm going to be an information systems specialist. I'm going to be a networking specialist. But this is computer science, guys. This is the big leagues. This is the pinnacle of everything you've been working for the last 3-4 years if you go and do a placement. Who's going to do a placement? Oh, okay. I suppose it's self-selecting really, isn't it? If you're here to asking about final year projects, you're probably not going to be off to do a placement next year. The placement people will be coming to this next year. It's a no-brainer to me. Right? You should be if you're a good programmer, if you enjoy programming, right, absolutely. But it's not just programming. If you plan to go into a career involving software development, absolutely. Okay? If you're not good at program but want to stretch yourself and learn, the project is a great way to get better at programming. Sometimes I think the difficulty we have when we teach programming on modules is we say, okay, this exercise you're going to learn about, classes and objects, and this exercise you're going to learn about, manipulating the DOM in JavaScript, etc., etc. Insert abstract concept here. What we very rarely do, and you'll do more of it in Programming 3, I think, and certainly in my Advanced Database and the Web module in the 3rd year, but what we don't do in the 1st and 2nd year as much as I would like, is give you projects, give you things to do. You know that tool set we gave you? Off you go and use it and do something. Okay? And there's no better way to get good at programming than to actually tackle a real problem. Not just solve an abstract, oh yes, demonstrate you can use this particular programming construct, but actually do something creative and original using that tool set. Okay? So if you're not good at programming, but you want to be good at programming, absolutely. I've had students' programming ability come on in leaps and bounds between the start and the end of their final year project, particularly when they've done it properly and they've gone through the process and they've gone through a proper design and they've come to understand software engineering as a whole. It's not just about programming. Okay? I've already said this. Most final year projects in this school will have some amount of software engineering involved. You will produce some code and you will go through some degree of formal methods to do so. Key thing, I've said this already, remember the software is only one small aspect, the application you write is one small aspect of a project. It's an academic piece of work, it's a holistic thing. It all goes together, okay? So there are people you probably know who I've supervised this year who are absolutely brilliant programmers who may well not end up with a first for their final year project because other areas they didn't do so well on, okay? So bear that in mind. It's a bigger prospect than just a bit of code. Okay, what kind of projects we'll be talking about here? And I'm going to do a bit of shameless recruitment here because I've got some projects in mind that I'd be very interested in talking to people about. The first few are people who have past project students. A rather nice HTML5 based collaborative music jamming application. Guy in Botswana lays down a drum track, and guy in Canada lays down an audio track, and guy in, I don't know, Argentina does the guitar, and they can mix and match it all together online. That was pretty cool. Android application, submitting multimedia reports from the field to their editors. Business relationship management applications. I've seen some very interesting games done before. And the bottom two are projects that I've got in my back pocket that I'd be very interested in having people potentially come and do. So if you are not quite sure what projects you want to do, if you don't have an idea, talk to us lot. Talk to the people around you. Talk to us old fuddy-duddy academics. Because most of us have research areas where we'd be very pleased to have people involved. And in my particular area, which as most of you know is electronic assessment, you all know Nooblab. Who misses Nooblab? Right. We'd be very interested in the final year project to actually create an editor to author Nooblab material. At the moment, someone needs to manually construct it by hand. And other tools for delivering e-assessments. So if you're interested in things like online quizzes and getting involved in maybe having your work used by other students, very interested in talking to you about it. Okay? So shameless plug if anyone wants to do a project with me. And of course I'm very much open to anyone who wants to do a project of their own devising with me. Yes, there is only one Paul at Kingston. Okay? So if you want to contact me about any of this or about any project ideas, you know where to find me. Okay? Okay.
I should say that when I organised this, I did say to every academic, you've got 5 minutes. So I think we can all say that some took a little bit more than their 5 minutes. One of the interesting observations I wanted to make is that because we're doing this, this is an appropriate time for you as you finish your second year and go into your third year. It's an interesting time for us because we're just in the middle of writing, of marking projects. So a lot of the feedback you get here comes from day to day what we're doing when we look at projects. The stuff that Paul's been talking about, things I was talking about earlier, come really to a peak here because we see so many examples of projects we'd like to see that were better. So that's the bit what my aspiration is for you for next year. My expectations aren't high because for the last 20 years I've said the same and it doesn't always happen. But for those that it does work with, we get some good projects.
Proving wrong.
So just remember, the first thing you've got to do is find a supervisor. We don't want 50 of you all going to Paul. You won't all get him. It'll go on a first come, first served basis if you want to go for Paul. It has both its benefits and its drawbacks, as you'll know. Pick a supervisor. Be proactive in what you want to do. Even if you don't talk to them, you choose somebody, and hopefully they can be allocated. Otherwise, it's random. You'll just cut it up in here and you'll get what lands. Okay. Thank you for coming.